So in section 2.9 we start exploring periodic table trends. And if you recall how Dmitry Mendeleev formed the periodic table, what he did was he placed elements that were similar to each other near each other. So all the elements that are kind of over here are going to have properties that are similar, and their properties are going to be very different from the elements that are over here. So the basic premise is that the further elements are away from one another on the periodic table, the more different they are from each other, and the closer they are to each other on the periodic table, the more similar they are. The elements that are most similar are those that are in the same group, and that's because they have similar outer electron configuration. Now, if I arranged a group of people so that those that were of most similar height stood next to one another, so I'm going to go from tallest to shortest, what do you see? Right, I'm placing these guys, I say to these four guys, stand near the person that is closest to you in height. And so what am I going to end up with? I'm going to end up with a line that goes from tallest to shortest, right? There will be a trend, yeah? Height will decrease left to right. So what we're going to expect is as we move across the periodic table, properties will gradually change from one extreme to the other. So it's a pretty simple idea, but that's what we're going to do now, is look at some properties of atoms and see how they change across the periodic table. Now, the good news is that these trends are all going to kind of vary along the same direction, aren't they? Because, you know, we've the way we've structured the periodic table, just like if I organize people to line up from tallest to shortest. Okay, so the first thing that we're going to look at is metal versus non-metal character. And as we mentioned before, all of the metals are on the left of the periodic table and all of the non-metals are on the right of the periodic table. And how we've organized things is such that the most metal-like elements are at the bottom left of the periodic table and the most non-metal-like elements are at the top right of the periodic table. So these guys down here do all of the stereotypical things that metals do, and these guys up here do all of the stereotypical things that non-metals do. And then there's a gradation in their properties as we move from bottom left to top right. So these are the most non-metal, and these are the most metal. So, you know, down the bottom here, you got like, you know, Norwegian black metal, and at the top here, you've got, I don't know, K-pop, BTS or something, right? And then in the middle here, you've got, you know, sort of, you know, top 40. Okay, so that's the kind of general idea. Another way of saying it, of course, is that metallic character increases towards the bottom left of the periodic table from the top right. Now, we know that as we go down the periods of the periodic table, what we're doing is we're adding layers of electrons. So those elements that are in the first period, they only have one shell. Those atoms that are in the second period have 2 layers of electrons. They have a second shell, and so forth until we get down to period 7, and they have 7 layers of electrons. So it's not surprising that as we head down the periodic table, the atoms get bigger. Okay? So what happens as we go across? Right? What happens as we go across the periodic table? So atoms are going to get bigger as we go down a group. Now, as we go across a group, we're adding electrons to the same layer. In this case, we're adding them to the second layer, right? So they're all going in at approximately the same distance from the nucleus. However, what is changing as we move across a period is that every time we move one space to the right, we add an extra proton to the nucleus. And the protons have a positive charge. So what happens is that all of the electrons kind of get snugged in a little bit because the nucleus increases in its positive charge as we move across. And that happens every time as we move across. All of the layers get kind of snugged in a little bit. So what we see as we go across is a decrease in size. So we get an increase as we go down a group, but as we go across a period, we get a decrease. So we have to put both of those trends together. Now I should point out that the trend as we move across this decrease in size, it's kind of modest. Right? You can see that here. These numbers are in what we call picometers. It's not that big effect. And as we move across the elements in the D block, the transition elements, you barely see it at all. Okay, so it's a more modest effect than in comparison to going down a group. So how does atomic radii increase? It increases as we go down, and it increases as we move to the left on the periodic table. So again, it goes from fluorine down to francium, F to F, but it's going in this direction. So we have increasing atomic radii, and we also have increasing metallic character. Okay, there we are. All right. And physical and chemical properties of elements are in general going to increase on or decrease along this diagonal line. Okay, so like I said, pretty short section. We just looked at a couple of periodic properties there, but they are important periodic properties, and we're going to be revisiting them later in other chemistry classes.